stealth technology, the internet, GPS in the palm of your hand, autonomous operation.
Technology is a driver of our times. Since its founding in 1958 in the midst of the Cold War, DARPA, the Defense Advanced Research Projects Agency, has been a driver of technology. Welcome to Voices from DARPA, a window onto DARPA's core of program managers. Their job? To redefine what is possible. My name is Ivan Amato, and I'm your DARPA host. Today, I'm pleased to be talking with Mr. John Waterston, a program manager since 2017 in the agency's Strategic Technology Office. We are recording our conversation from our respective homes as we do our parts to slow the spread of COVID-19, and because we're not in a recording studio, you might hear ambient sounds like traffic, planes, and birds. Prior to arriving at DARPA, John was a senior program manager in SRI International's Advanced Technology and Systems Division. Over a number of years there, he led defense research programs in cyber warfare, Arctic sensing, unmanned vehicles, among other technical areas. With his pivot from SRI to DARPA, John brings with him interests in maritime autonomy, undersea warfare, distributed sensing, and non-traditional communications. John surely developed some of those interests, at least, in his 12 years in the Navy, during which he lived on 3 different submarines and learned how to operate a nuclear reactor. He continues his military service as a commander in the U.S. Naval Reserves. John received a Bachelor of Science degree in Electrical Engineering from the U.S. Naval Academy and a Master of Science degree in Electrical Engineering from Stanford University, earning that degree in 2001. John Waterston, thanks for joining me in this conversation.
Thank you, Ivan. This is a great opportunity to talk with you today.
So in just a bit, we'll dive into some of the programs you are overseeing. One of these seems like you're hoping to install a sensory and nervous system into the planet's oceans. Another one has to do with developing a backup to GPS in case that must-have system were to suddenly become unavailable. Another is about creating a GPS-like system that works underwater. All of them hugely ambitious. But before we hear more about those programs, I'd like to know something about the influences and experiences in your life that turned you toward electrical engineering and a career, at least a first career in the Navy.
One of the things that's always driven me, I've wanted to figure out how things work and kind of work at a fundamental level. And so when I was thinking about going to school, electrical engineering allowed me to understand how computers, phones, and all of the digital communications of today was working. So that's kind of what attracted me to electrical engineering. Is I'm one of those people who isn't satisfied with just some black box. I want to kind of get down into the nuts and bolts of how things work. With the Navy, I thought it would be a great opportunity to see the world. I'm a big believer in making decisions as you move through life to maximize your opportunity. While growing up in high school, I was involved with the Scouts, so I always had kind of a big service component in my life. I don't have a military family, although my grandfather served in the Navy in World War II, but I went to the Naval Academy not knowing what I wanted to do. I feel like maybe I don't know what I want to be when I grow up. I probably still don't know what I want to be when I grow up. And maybe DARPA's been a place where I can explore many areas that interest me and show success. The Navy trains everyone to do a very important national mission. And so again, I picked submarines, and I think I learned a few things along the way, and it's been very helpful.
You brought up the idea of the black box, and particularly in our electronic realities, we have so many of these black boxes in our lives. And yeah, that's why I've actually always admired the electrical engineer, because that is a profession that often will have some sense of just almost everything about those black boxes. The transistors and other devices that are incredibly miniaturized in them, how they all hook together, how software is interacting with them, how they're actually creating the capabilities. So I think you chose well. If you want to know how things work these days, you probably couldn't have done better than an EE training. And then I also want to just follow up on your sort of experience in the Navy and working on submarines, and one of the small subpopulation out there that actually knows how to run a nuclear reactor. I'm wondering if any of that experience and any of those skills that you developed in that setting is helping you in your new role since 2017 as a program manager at DARPA.
Well, it still feels new. That's another thing about life at DARPA. It goes by super fast. But getting back to life on a submarine, everyone on a submarine is responsible for everyone else, right? You have to be an expert at your job because the ocean is cruel and ships really shouldn't be able to submerge below the surface of the ocean and survive. And so the basic thing that is taught to every submariner is you are responsible and you have to become an expert within your area of influence and know everything about the ship that you're living on. So while on a submarine, I was more focused on mechanical systems, hydraulics, water, the nuclear reactor, and less on the black boxes of computing, I still use those tools every day to do an important mission. And that's what really attracted me to submarines in the first place, was I felt like they always were at the tip of the spear, doing the coolest missions around the world, and I wanted to work with people who had volunteered to do that while I played out my active duty service.
Okay, and because you're one of the few people I know who has lived on submarines underwater probably for extended periods of time. Now, I know you were on various missions that you just can't talk to me about, you can't talk to your kids about, you can't talk to your wife about. But my guess is that there are some pretty crazy things that probably happened, very fascinating, interesting things down there. Is there something that just, surprised you that you actually can tell us about?
There's a lot of great stories on board submarines. On my first dive to test depth on the USS Jimmy Carter, my job was to check to see if a hatch was going to work at depth. And so the thing is I climbed up into this hatch and I knew the pressure of the ocean was pushing down. There was no way it was going to open, but I had to move the mechanical linkages to make sure that it wasn't binding under the extreme ocean pressure and open it to its fully open position. And all the scientific knowledge in the world says, yeah, there's thousands of PSI of pressure on the outside of this, but here you go, you're opening it to the max open position on the inside, to, unlocking that latch, and just to make sure it would work. And boy, that was one of those, you got to believe in everything that's like that. There's similar things like crawling down the end of a torpedo tube or things like that are very unique experiences that you just won't find in other Navy ships.
Well, thank you for giving me some sense of some of those moments on the submarine. So just want to keep moving forward here a little bit in your career before we get into talking about your programs. And so just before coming to DARPA, you were at SRI International for a number of years. SRI has had a bunch of touch points with the agency, for actually decades, including some historically noteworthy projects in areas, like early computer technology, robotics, human-machine interfaces, things of that sort. But I'm just wondering about how you got to DARPA story. How did you go from SRI to DARPA?
It's through SRI, right? I mean, I first was introduced to SRI in graduate school in Palo Alto. And when I decided to get out of the active duty Navy, I went back to SRI to kind of fuel my intellectual curiosity. And the great thing, when you're there in Menlo Park, you see the first mouse, you see the cocktail napkin where the internet was kind of first sketched out. You meet the researchers who built Siri and many other interfaces like that, okay? And
all of which have DARPA connections.
Exactly. And so I was given the charter to build a maritime portfolio at SRI based on my naval experience, and ended up winning 2 DARPA contracts, started performing on those contracts, and interacting with the people in the DARPA building. And I realized that I can move from, industry into the government and continue along this trajectory of kind of making really interesting solutions for a lot of my naval partners.
Yeah, so you're bringing in also that additional kind of special experience as being a former performer, which is DARPA speak for a researcher on contract on a particular program. And I imagine that's really serving you well now on the other side as a program manager who is giving contracts out to others to work on your programs.
Well, you understand some of the dynamics around what is the business case for this, or what might management be needing from the principal investigator. So you understand how this negotiation works between government and industry as we're all trying to create these interesting technologies.
Now let's dive into your programs. And for the first one, I guess it's more like we're floating into the program because thousands of floating sensors are going to be a key component of it. I'm talking about your Ocean of Things program. John, I'd love you to tell me and listeners about this program. What's the need you are trying to meet with it, and what have you and the researchers, the performers you have contracted to work with on the project achieved so far?
Well, Ocean of Things was born of my understanding of the ocean. It's in this realization that it is so immense, covering 70% of the Earth's surface. And even with all of the ships, all the aircrafts, all the satellites, and all the existing sensors, we are severely undersampling this environment. It's a desert of data, and we need to come up with a new way to sample it. And then with those new sensors, these Ocean of Things floats, what can we do with this new high-resolution data to serve existing academic, commercial, and military users in the maritime environment? And all that seems pretty broad, but to be honest, with all the investment that has been done in the commercial space with things like cell phones and microcontrollers, you're able to get very low power, low-cost processors that are able to now make decisions while floating out in the ocean and then communicate what those floats have found back to cloud data storage so that our performers can do data analysis on this. And that's a game-changing paradigm.
I want listeners to actually have in their minds just some sense of just how cool and vast and multifaceted the system is that you're envisioning here, and in fact are well on your way toward bringing toward realization. So what would be good is if you could focus in on the main components. So I want you to talk a little bit and be descriptive about those floats you talked about, how they're communicating to a system of satellites, and then what is going to happen with the data that the floats are relaying through those satellites to other analytic systems on the ground.
One of our technical areas, and that's how we break down our programs at DARPA, is really delivering this float hardware. In phase one, which we just completed, we had 3 performers who were building kind of environmentally friendly floating sensors. And these sensors were not just traditional maritime scientific measurement devices. They were more like 3-year-old cell phones. And because they were 3-year-old cell phones, they all had the same things that you do on your cell phone. You have a microphone, accelerometer, compass, GPS. And to limit the overall cost of these devices, we actually had mission sensors as well, things like hydrophones, cameras, and software-defined radios. And so what we're trying to do is encapsulate those sensors into a platform that would last in the harsh ocean environment. And that is a challenge that's really difficult because the ocean environment, again, like I said, is so harsh, and these floats are trying to be so low cost. So we're purposely pushing at a dissonance because traditional buoys and ocean-going platforms are very expensive. We don't build lots of them, so we put really exquisite sensors on them to extract the most data. This is solving the exact opposite corner of the spectrum, where we're trying to build lots of sensors that are commercial quality and then put them into the ocean environment. And my thesis is if you have hundreds of these lower quality sensors, you can augment existing sensors and fill in the gaps in ocean understanding. And one of the neat things we did in phase one was really look at the materials. One performer used wax-coated cardboard to be environmentally friendly. One performer used glass as encapsulation, kind of be more like, the traditional Japanese fishing floats that you might see. And then one performer was more traditional in the sense of they used aluminum but used wood to provide the buoyancy. So these floats are designed to operate for months on their own, often solar powered, and sense the environment that they're in. And then the neat thing is, since they have processors, they can realize when there's a change to that environment and report that change back to me and our servers in San Diego. So right now we have floats in the Pacific, the Gulf of Mexico, and even the Mediterranean Sea. And We do that via Iridium satellite. So Iridium's more of a medium altitude satellite. What we're using is their small burst data service. Our floats now tweet, in essence, 340 byte messages every 15 minutes back to our servers where we can check their status, see what they're seeing, and generate a bunch of interesting data products for our user community.
I love the tweet analogy because, and it's pretty good, right? Because the original idea of Twitter was, it's sort of like, what are you doing now? Or what are you observing now? And so now what you're talking about are having all of these floats, you tell me, tens of thousands, hundreds of thousands of floats throughout the oceanic systems?
So this year alone, we're building over 5,000 floats of a new design that's smaller, lower impact, and has more sensors on it. So we're increasing both in the number domain and in the kind of the impact or modalities of sensing that we can achieve. So with thousands, now we're going to start to really test the thesis that I presented to you, where number might be more important than precision.
Right. Now, what also excites me so much about the ocean of things is the way it actually can be of value to, many of society's sectors. So, of course, we're at DARPA. There's a D in the beginning of DARPA, Defense Advanced Research Projects Agency. So surely things like situational awareness and surveillance are part of what you have in mind, what DARPA has in mind, what DoD has in mind with the ocean of things. But you've also spoken about how valuable it can be kind of as a new sensory system in the ocean for fundamental science and just for monitoring the condition of the Earth.
You've got that exactly right. So when we did a survey of the existing sensors that are out there in the ocean, we find out that, well, if you're, Woods Hole Oceanographic Institute, you build yourself a sensor. Great. It collects your data. It's out there. Some of the new ones are staying out there for 4 years at a time. They're great. But it's very similar to the same sensor that the Naval Oceanographic Command could deploy, or a naval surface ship could deploy to get situational awareness, or an oil and gas community member would employ. And so instead of each of these individual entities pulling up their own stovepipes of information, I realized, why don't we figure out how to build a common platform that generates utility for multiple people simultaneously? It's the same fundamental data. And like you said, DARPA, with its defense hat on, is very interested in understanding the situation that all of its forces will be operating around the world. The thing is while tracks and figuring out where all the activity is kind of important in that, you still have to build the foundation of the environment to which those activities can be built upon. So a better understanding of the ocean currents, temperatures, the waves, the atmospheric conditions on the surface of the ocean, all of those things impact the activity layer and therefore the operations of the military in a specific area of interest.
It's a reasonable thing to think that you will succeed at this and that we will in time have this vast distributed sensory system in the ocean. When you have your happiest moment about that success and you think about the greatest good that it might bring us, what comes to mind?
It's weird to say, but improved weather forecasts can have a huge impact around the world. I know that just recently we had hundreds of floats in the trajectory of Hurricane Sally in the Gulf of Mexico. And what we were able to do is we realized that there was a warm core eddy that had kind of broken off from the Gulf Loop current that kind of is the formation of the Gulf Stream and was sitting south of Mississippi. And the ocean models of the current variety being used in oceanographic and meteorological research had this eddy in a slightly different location. In the last 24 hours of being offshore, Sally intensified. I don't know if you remember, she, I think, went from a Category 1 hurricane to a Category 3 kind of rapidly right before getting to land. And we think that that intensification was due to the location of this warm set of water. And it's on a scale that wasn't able to be resolved in kind of the existing models that are used by researchers today or used by those forecasters today. Our drifters, by drifting on the surface of the ocean, their velocities were able to correct that model, and we kind of had an internal thing. So what we hope to do is assimilate our float data into those models. And then the next thing is meteorology is starting to fully couple the ocean with the air. And now understanding like where it's raining in the ocean, kind of a question that we've never even tried to ask before, I think will be in reach of these sensors. And then we'd be able to feed that huge heat transfer between the sky and the water, and similarly from the water to the sky in the case of a hurricane or other cyclonic storms, can show drastic value in improving weather forecasts. And that matters to the military.
I guess a key here is the granularity of the data, which I think maybe perhaps is unprecedented for feeding into these large-scale ocean atmosphere type of models.
Exactly. And you've seen it happen on the terrestrial weather forecasting. Everyone can put a weather station in their backyard, connect it to the internet, and sites like Weather Underground and weather.com start using this hobbyist data feeds to improve their forecasts. It doesn't get rid of the National Weather Service instruments at the airports and at key strategic locations and them sending weather balloons up into the stratosphere. But what it does is allows them to make really fine-grained forecasts. If it's raining here in Vienna versus raining in Arlington, right? Something that's only 4 to 5 miles away. Bringing that kind of understanding to the ocean is unprecedented. There is no way to do that today. So that's at that environmental layer what I'm excited about. In the activity layer, though, is understanding where are marine mammals. Something, again, today in 2020, we know where whales live by putting people out in a small boat and looking at them with binoculars. And we record those censuses and kind of get a sense of where they're feeding, where they're migrating, and how they interact with ships and in their daily life. And so if Ocean of Things can help automate and understand where those marine mammals are, we can have less impact to those populations. Plus, we can also, from a commerce aspect, we don't have to unnecessarily slow down ships, or we can slow down ships when we need to protect these marine mammals. So there's a great example of a activity scenario where this ubiquitous distributed sensing can really help improve overall state of the ocean awareness.
We're going to move to another program in just a second, but just two further questions here, and one's following what you just said. So there are two things that come to my mind. When I think about thousands and thousands of floaters, I do think about, impacts with vessels out there, even though they're, you've said they're made of things like wood and cardboard in some cases, though I think maybe other materials. And then the built-in plan that these things will scuttle for when they become obsolete or their batteries die, which means that they will be remaining in the ocean environment. And so just talk to me a little bit about those aspects of the program and the environmental consequences.
Yeah, so we have always been very sensitive to that trade, right? There is no such thing as, for free, you participate in the environment. What we have done is spent a lot of time minimizing the amount of plastics that are in each one of these floats. We do want to prevent them from interacting with humans and other marine mammals. They do scuttle so that they don't end up on beaches or in marine protected areas, right? They have keep out fences from those kind of undersea national parks and international equivalents. But the thing that I'm trying to do is derive value from the data they collect so that the return that we get from these floats is much, much greater than any environmental impact. And I think once we have a distributed set of these sensors that is able to be used by many different people in the community, whether it's academic, commercial, or military, we all have much, much more value from that. I look forward to seeing if my thesis holds true, and as we scale this, have a lot of people involved.
Right. And while it's under your wing, and you're still a DARPA program manager, because as we know, program managers stay just a number of years and not forever, what is still to happen in the program under your wing?
So it's really the scaling out. We obviously have our manufacturer who's working to build 5,000 of these here in the second phase. We're also then trying to build more advanced detection and anomaly things. So can we put a whale classifier into that float? Can we put something that detects the health of GPS? All of these things have really important uses for downstream users, and delivering those to a military customer and deploying it for their use is something I want to see done before we're complete with the program.
Okay, well, thanks for that description of the Ocean of Things project. May you succeed with that, because I think all of us will benefit from having a better understanding of what's happening in the ocean. And now I want to move to another one of your programs. This one I think you inherited. And this one is called the Spatial, Temporal, and Orientation Information in Contested Environments Program, or known for short as STOIC. This one resides within a long DARPA tradition of pushing precision clock technology forward, to new levels of performance. And the thing about STOIC that gets me is that it's kind of driven by a fairly alarming question when I think about it, which is, what if the Global Positioning System, GPS, were to go down? Tell me about STOIC, what you do hope to achieve with it, and what is its status.
Yeah, GPS is a victim of its own success, right? Because we now have ubiquitous positioning on the Earth's surface, and with that positioning, we have very accurate clocks coming from the satellite. While people use GPS for positioning, many computers today use GPS for their timing. And the relationship between positioning and timing is so tightly coupled. So when I got this program, I had actually interacted with it in its earlier state at SRI. So I wasn't ignorant of what it was trying to do. I kind of had a hint. And where this idea came from was, are there RF, radio frequency sources, that are available kind of in the atmosphere today that can be used for positioning? And the signal that STOIC started working from was lightning bolts. And, before I would have said, how can you use lightning bolts around the world to figure out where a ship or aircraft is? And so the earlier program, which was called Aspen, really worked to try to make a positioning system just from these lightning sources around the world.
Just to give listeners a sense, is it the very low frequency signals that are coming from those lightning bolts and therefore travel great distances that you're looking at there, or is it some other part of the lightning bolt?
No, there is a very low frequency signal that occurs as that discharge from the lightning bolt, whether it's cloud to cloud or cloud to ground, occurs, and that travels for tens of thousands of kilometers. And there's a great network of lightning detection systems worldwide. Happens to be that over the Amazon rainforest, there's almost continually lightning storms. You wouldn't know that until you kind of start investigating this. And this was an interesting source. STOIC continued down that path and looked for generalized VLF sources to do this localization. And that was one area. The other area is building really precise clocks. So just like we have at the Naval Observatory, which is the master clock for the United States, how can you transfer time from that clock and have it contained on a ship, a submarine, a plane? And so therefore, we're always synchronized in our actions. And so this idea for very precise clocks that won't drift in time, this is parts per billion types of precision that these clocks have to maintain, was the second kind of main effort here. And we ended up looking at laser-based clocks and how those would support this precise timing in the STOIC program.
Right. And then ultimately the idea then is this would provide a GPS-like capability, even if the GPS system went down. So this means that the various military assets would have that capability, even in the event, again, that GPS went down. So this means that the U.S. would be able to carry out its military missions regardless.
Exactly. And so this was kind of a different program in the sense that we're working on the fundamental services that a military platform needs. You need to know where you are and what time it is. And you want to build in as many diverse position sources, whether that's celestial navigation from ships of old to the STOIC based VLF navigation to GPS, or things like magnetic navigation and other modalities, right? That's the overall goal of where that localization part of precision navigation and timing goes. And this other part is, now if you know where you are, knowing what time it is allows you to synchronize operations across the battle space. So how does a plane above know when to talk when compared to a ship below? How do we know when various activities have to occur in the battle space? And how do we know when I sense something, it was of this exact event? And so we can all be aligned moving forward. And that's a key military capability.
In the context of the life cycle of a DARPA project, where is STOIC?
STOIC is almost done. We're excited about the results, and we've transitioned the capabilities and technology to the Navy so that they can put it in on their ships and aircraft. So this is an exciting thing to see these concepts coming through maturity in DARPA, those investments showing benefit, and then transitioning over to the fleet.
You're just mentioning really what for DARPA is kind of the finish line, that word transitioning you used, because DARPA wants to investigate all the kinds of technologies that are possible and that would serve the cause of national defense. But if it goes nowhere else, then it doesn't really do as much as if you actually hand it off to an end user. Like in this case, it could be in the Navy, right?
Yeah, exactly. And that feedback they get from that in informing the development is so valuable, both to DARPA and to the Navy, so they know what's possible. So really, it is informing both sides of that interaction. It's a win-win whenever we get a chance to experiment and go interact with the various military users.
Okay, and since we're on the subject of GPS, I just want to briefly touch on one more of your programs. It's called Poseidon. That stands for the Positioning System for Deep Ocean Navigation, which essentially sounds like to me a GPS system for places where used to be, like I'm referring to submarines. So for submarines and autonomous undersea vehicles, GPS for the underwater world. Tell me a little bit about that program and where it's at.
That's the exact purpose. So when you're underneath the surface of the water, GPS isn't available. So by definition, GPS isn't there. And so traditionally submarines have operated with very precise navigators on board so that they don't need to put a periscope up and come above the surface of the waves. So what Poseidon did was build a set of active transponders that would operate in an area of interest that would provide a GPS-like signal to a submarine or an unmanned underwater vehicle. Again, positioning is one of these key enablers for operations in the undersea. And by providing that as a service, like GPS does to everyone on land, it would be very, very valuable. So we transitioned this hardware to the Navy, and they're working at implementing it into operational systems today.
It is interesting to me to hear this from a historical point of view, because the original step toward systems like GPS was, I believe, the transit system, which is a Navy system. And the whole point of that was, or at least one major point, was to reduce the time the nuclear submarines in our defense platform would have to actually surface to get a reading from a satellite. The idea was to minimize that, hence the transit system, which was more sort of a Doppler-based system, which led to GPS. And now you're talking about Poseidon, which actually, it sounds like, achieves what was maybe sort of ultimately in the minds of the people who developed transit, which is being able to get a position underwater without actually having to surface at all.
That's right. And it provides that infrastructure that you rely on to understand where you are at all times. And so if completely implemented, a submarine would never need to go above the surface of the ocean to figure out where it's located.
Right. And not only to figure out itself, but the reason why I would not want to do that is because it becomes vulnerable to detection by adversaries.
Exactly. The most vulnerable, right? And that is the submarine's advantage, is its stealth. And so limiting any opportunity to be detected is a win for a submarine mission.
That was quite a whirlwind, John, those three programs, STOIC, Poseidon, and Ocean of Things. You really do have your hands full, I have to say. Now, as someone who has been on the ground in the military, or in your case, boots underwater, and who also has been in the business of technology development, so I'm thinking of your work at SRI, how would you characterize DARPA's place in the innovation ecosystem?
So what you don't mention about my background, Ivan, is I was a management consultant. So I had a stint post-active duty where I was focused on businesses improving their overall operations. And so I feel what we do at DARPA is being a venture capital fund, right? We are a place where you can bring ideas and mature them so that they have the most impact going forward. So at DARPA, we don't have excessive bureaucracy. We're able to move fast. We got this advantage that everyone's motivated to succeed and get ideas that have the most impact. And that's what makes me excited every day that I come to work. It makes every day different. And those two things kind of keep me pushing, now for almost 4 years.
Yeah, and just following on that a little bit, I mean, one of the things now that I've been at DARPA for a while that really comes to my mind is, how is it that humanity at all can go after some of the incredibly ambitious technology visions that are just sort of part and parcel at DARPA? When you think about it, a lot of private industry would not take the risk. But what DARPA is doing, and in programs like you're running and other PMs are running, is to take the risk down. Right, enough so that ultimately you can get to that transition where it's not insane on the part of another part of the military, another military service like the Navy or the Air Force or even commercial entities, companies, to actually take the baton and then take the technology to the finish line. So it's that sense of de-risking technology that I find interesting.
Exactly. And, I'm not judged on success of my program. So I'm very comfortable operating with a lot of risk. I've had a lot of failures along the way as a PM at DARPA. We've gotten rid of programs, things didn't succeed. They didn't fire me. What they did is say, what did we learn from it, and how do we make the next iteration of what we do better? It's often said to fail fast, and we take those losses and we turn them into something valuable. And that what makes DARPA a very special place.
Nicely said. That sort of winning role of what's on some levels might be considered failure, but really what that is a form of data and understanding that helps you move forward in the end. So nicely said. I have one other question, which is not even a trick question, but it's, what are you appalled at that I didn't ask you?
I always like to tell people that DARPA doesn't have a secret laboratory in the basement. We are a business operation. We're trying to get money out in the hands of researchers every day. And so I think a lot of people are either afraid to come talk to program managers, bring their ideas to us. I think most people will find that while we're busy, we're in the business of ideas. And if you have an idea and a new way of doing something, we're always interested in talking to you.
John, as you know, program managers are at DARPA for just a finite number of years, could be 3, 4, 5 years. Sometimes they actually do come back for a second tour of duty, but you're not there forever. So I'm just wondering, as you think about the end phase and transitioning out of DARPA at some point, do you imagine in your role in the reserves as maybe going back into a submarine for another 90 days underwater? Or are you finished with that sort of service and will think of other things?
Once you've been away from submarines from, I think, over 2 years, you have to be requalified, and they won't take someone old and slow like me. So I'll probably never get back on submarines. I'll stay working hard in the reserves, and I got to figure out what to do when I grow up, whether that's go to industry, start my own company, or help others continue to innovate. These are things that are kind of near and dear to my heart. Although I'm so busy these days, I don't have time to often think what the next steps were going to be.
I suspect that you're going to have lots of options given all of the experience that you have had and what you continue now to accrue at DARPA. Well, you certainly have given me and also our listeners a lot to think about and imagine with respect to the new ways that we might be able to understand the ocean and what goes on in that vast portion of the planet, which you actually have seen also from within, that is to say underwater. It amazes me to think about that. Also, we've learned about incredibly cool technologies like very low frequency signaling from lightning and amazing optical clocks that can help provide GPS where it is not available. That actually reminds me of sort of the mix and match game of different technological systems, which has been a theme of DARPA's innovation style. So cool to hear about the ways you are putting sort of systems of systems together. And this is a long way of saying, John, that thanks for sharing this time with me and telling such engaging tales of life as a DARPA program manager.
Thanks, Ivan. I want to encourage everyone out in the audience to engage with DARPA going forward. Check out the data from my floats. They're available at the DARPA website at oceanoftings.darpa.mil. There's going to be more to see in the future, and I look forward to hearing people's thoughts and ideas moving forward.
Okay, you heard it from John, listeners. Get in touch with us. And thanks, listeners, for sharing this time with us. I hope you join us again for the next Voices from DARPA. Thanks also to Ben Sullivan for his partnership in producing this program. For more information about Mr. John Waterston, the programs he runs in the agency's Strategic Technology Office, and the other breakthrough technologies DARPA is working on, visit darpa.mil. And for links that enable you to download this podcast, go to the Voices from DARPA page on DARPA's website.